The composition of phosphate rock, you need to understand the chemistry, the mineralogy. Like soil, phosphate rock is not a compound, single compound. The major rock is called apatite, that's the phosphorus mineral. Then some rocks have calcite, dolomite, quartz, and so on, gypsum, and etc. But the major source we call phosphate rock because it has phosphorus minerals. Now, I like to point it out that some of the phosphate rock do have the calcite and dolomite. So if you try to find the increase in soil pH due to phosphate rock, you need to distinguish the increase in pH is due to apatite, neutralization by soil acidity, or the soil pH induced by calcite and dolomite. If calcite and dolomite, the rock has significant amount, it can increase like liming, increase soil pH very, very high. But if the apatite by itself, the increase in soil pH, not so much. I'll discuss this later on. But beforehand, I need to point it out is that this is the calcite and dolomite. And then this apatite, this word is in Greek. If you check the Greek dictionary, you have apatite. That means to deceive or deceiving. So we are dealing deceiving minerals. It took many, many years for the geologists and mineralogists to figure out this compound has 10 calcium, 6 PO4, and 2 fluorine. So they say, oh, it has a fluoro. And this is called fluoroapatite. This is the deceiving minerals, contains fluorine. That's the name of the apatite. But now we know that even this fluoroapatite is not the representative of apatite. It's this called carbonate apatite, called francolite, which has this isomorphic substitution. You have a carbonate substitution for phosphate, and so on. I'll explain more on the next slide. So this apatite is called deceiving minerals. So no wonder, so many years we are still being fooled around by apatite. I spent 46 years on phosphate rock, and to tell you the truth, I still do not fully understand. Probably 80%, 85%. The remaining is still unknown. Unknown, like your Malaysia's airline, MH17, disappear. Unknown, don't know what's going on, eh? So sometimes you look at the data, I say, doesn't make sense, but it's there, So it's because deceiving minerals, deceiving minerals. Pointed out is that this apatite, of course, is most important, and that we want to concentrate on the composition of apatite. The structure of apatite, in here you have a calcium, 10 minus A minus B, and this is a long formula, but okay. I want to draw your attention is this called carbonate substitution for phosphate. CO3 can substitute PO4 in this apatite structure, and it has a carbonate. Be sure this carbonate is called apatite bound carbonate, not this free calcite and dolomite which has this carbonate. It's apatite bound carbonate is important, not free calcite and dolomite. Because one time there's a company in India, their rock called Mussoorie phosphate rock has a lot of calcite and dolomite, and they said that Dr. Chien said that high carbonate content in the rock, the reactivity is very, very, very high. So they say our rock is very high, has about 30% of carbonate, and turning out the carbonate is in calcite dolomite, not in apatite. So that's misleading. In this case, you can see that carbonate substitution for phosphate. Look at the carbonate substitution for phosphate, it's -2, this is -3. After substitution, you got one negative excess charge. You got it? This is electro-neutrality is not balanced. So one way to compensate this is CO3 plus 1 fluorine. So -2, -1, -3. Compensate is -3. So it's a zero charge. But based on the statistics, the probability of having this CO3 plus 1F for PO4 is only 40%. 60% of substitution due to this -1 is the sodium substitution for calcium. That you got 1 plus 1. So this +1 and -1 balance out. And that's why you have a sodium substitution for calcium. And the probability of 40% because you have a fluoride. Normally you have only 2 moles of fluoride, and this is 40%. So this is 0.4, it's 40% here. Okay? And then in a natural environment, marine environment, you have Magnesium substitution for calcium, that of course +2. You got no problem of electro-neutrality. So that's because zero charge. So basically, this is the formula of general apatite, okay? And just be sure, carbonate substitution of phosphate, and apatite reactivity or solubility increases with carbonate substitution for phosphate substitution. Why? The more carbonate in apatite, the higher the reactivity and solubility. Because these two structures are incompatible in ionic structure. They are not the same type of ionic structure, incompatible. Give you an example in here. Carbonate is a planar structure, plane. PO4 is tetrahedral. Do they match? They don't. So after substitution, the structure will become more unstable or less stable. Or when the structure is more unstable or less stable, means reactivity is higher or solubility is higher, isn't it? According to Pauline's rule, if you took the general chemistry, Nobel Prize winner of chemistry, he passed away a long time ago. The coordination of ions in the structure, the X number must be less than 1.33, the maximum. If the substitution carbonates over 1.33, the structure is so unstable, it collapses and then transforms to other mineral species. So you will never see this CO3 would be over the carbonate substitution. The X number more than 1.33 is impossible, according to the Pauline's rule. So you see that this planar structure to substitute PO4, the term is they are incompatible. Incompatible. In the United States, if a couple wants to file divorce, you don't need to find the excuse, say, he or she has extra affair, or the spouse is alcoholic, abuse, or whatever. All you need to say is, we two are incompatible in marriage. Then the judge will look at, okay lah, it's approved, the divorce, okay lah, it's approved. Incompatible. So you can see that, okay lah, after substitution, the reactivity increases, solubility increases. That's due to the incompatible substitution. So here give some example, North Carolina, GAPSA to Uganda, Sakura. This is total pedophile, this is 2% citric acid, and this is the empirical formula determined by X-ray diffraction. And if you look at the CO3, the North Carolina is 1.23, that's very close to 1.33, very, very high. And GAPSA 1.16, this number sometimes can be changed, it's not precise, but close to the level. And then to Central Florida, Tennessee is lower. You can see the 2% citric acid decreases along with decrease in carbonate moles of carbonate moles in the apatite structures. And to this Uganda is almost zero. So that's the pure flow apatite. It's igneous rock. Solubility is extremely low. And you can see that total pedophile, nothing to do with reactivity or solubility. Even this 38% high, so the higher the total pedophile, the worse of the reactivity of the phosphate rock, because no substitution. So your PO4 will be very high. So let's remember, total pedophile is not a good index for rock's reactivity. I published a paper in the Soil Science Society of Malaysia's newsletter back in 1998 or whatever. Newsletter. Title is Total pedophile is not a good index for reactivity or for desertification and so on. So that's, you need to be aware of the carbonate substitution. Now, this is something new because in 1995 or in the past, I never talked about this. This is related to the Biova phosphate rock. Why Biova phosphate rock is so reactive?